Hey geometry team, and welcome to Unit 6 Day 2. We are going to continue talking about congruent triangles, but now we're going to actually do two-column proofs using the different congruency setups that we learned in last class. So if you recall, we learned side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg, right. And so we're going to use those now within proofs to tell us, whether two triangles are congruent or not. And so let us get right to it and start talking what you're going to look for and how to do this. So there is nothing new today. This is just taking everything you've learned this entire semester and putting it all into one proof. So the first thing you're going to do to prove triangles congruent is look for three parts that you either can see are congruent or that you can prove are congruent. And you're going to be looking for parts that meet your side, 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 angle, angle, side, angle, side, angle, angle, side. Remember, that's the same thing as side, angle, angle, so you're okay, don't panic. And then your hypotenuse, leg, right. So you're looking for any of these that you can find. So you look in the triangle and the other triangle and look for parts that you can prove are congruent. You need three. Then you're going to show each of those are congruent somehow in the steps of your proof. Maybe it was given, you can say these two things are congruent because it was given. And then you move on trying to find each of your three pieces. Then at the end, you say, yes, these triangles are congruent, and you tell which congruence postulate you used, which of these you used to decide these triangles were congruent. And the only way to really use this and learn how to use this is to do it a few times. And so we're going to go over a couple here in this video, and then your assignment will also be to just practice looking for and then saying and proving these things. So to start off with, I have this picture. This is a parallelogram, and I am given that segment BC is congruent to segment DA. So the first thing you want to do on these proofs is mark what you know. And so since I know that BC is congruent to DA, you want to mark those on your proof. Then you see that segment BC is parallel to that. And so I'm going to use the little arrows to show that those are parallel. And I know there's a glare here, but I said it was parallel. You know it's parallel. Okay? And I want to prove that triangle ABC is congruent to triangle CDA. Now, if you recall from last time, that means we're trying to prove that angle A and angle C are somehow congruent, or that angle B and angle D are somehow congruent, and that C, again, is congruent to A. So you want to make sure that when you're proving this, you prove the right stuff is congruent in order to get to your right answer. And so we start off with our givens, and I have pre-filled these because givens are givens. Now, if you're really lazy, you could, in a proof, take both of these. Oops, I forgot. I can't move them around when it's in this. So let me set this back up, and I'm going to take it out of presentation mode. So there now I can move stuff around for you. Okay, so I could have taken this and put it on the same step, and because they're both givens, and you can just save yourself a line of work to put all your givens in the same line. I'm going to keep it separate just so you can see that there were two givens, and so I have this was given and this was given. Now I'm going to start looking for stuff that I can say for sure is congruent. Well, I started off with one thing being congruent, and I'm even going to label that. I know that I have a side being congruent. So chances are I'm going to be using side, 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 because that has sides in it, or side, side, or angle, side, angle, or angle, angle, side. Okay, so I'm looking for one of those ones that has a side in it, since that's something I was given. Well, I'm not given anything else. So now you have to start hunting and using all the different properties that you already learned about lines, parallels, triangles, things like that to prove things. And the next clue is in your given. I was given that the lines were parallel. So you think back to that parallel line unit we did, and you go, if I had two lines that were parallel, then if I cut them, I've got all sorts of relationships with my different angles. And so in this one, I know that this angle right here and this angle right here are alternate interior angles. And alternate interior angles are congruent. So I can use that. So I can say now that this angle, this one here, is angle BCA. So angle BCA is going to be congruent to angle CAD. And so I look through here, and oh, this one actually has them written out for me. So I could have written this right here. Angle BCA is congruent to angle CAD. That's what you would do if you weren't on a computer. But if you're on a computer, you can look and go, oh, here is that thing said right there. So I can just come over here and grab it and put it in that slot. Okay? So you either write it or you grab it and put it there. Now this is proving to me that I've got two angles being congruent. So I'm going to mark that gives me some angles. And I've got those angles marked here. And then I already had that some sides were congruent. Just going to clean that up a squish. Okay. And then you go, well, how did I know that these angles were congruent again? You always have to have a reason. You think back to what we said, and oh, I said that worked because those were alternate interior angles. And so that was my alternate interior angles theorem. Or you might just write alternate interior angles are congruent, or the ulterior, whatever, something that explains that you had alternate interior angles being congruent so that you could say that those angles were congruent there. So now I have a side, and now I have an angle. Because there's got to be something else congruent here. And so you look and you look and you think, and then you realize this triangle on top that's blue is connected to this triangle on bottom that's orange. And sometimes using those different colors helps, because then you see, oh, the blue triangle and the orange triangle here, they are sharing a side right down the middle. They both have that segment in common. Well, if you recall back from the start of the year, you are congruent to yourself. Any geometric object is congruent to itself. So this line in the blue triangle is congruent to itself in the orange triangle. So you could say that segment AC is congruent to segment AC. You can say it's congruent to itself. It seems obvious, but remember, when you're doing a proof in geometry, you have to list everything out, because geometers and mathematicians are stinkers, and we always try and like to catch you in mistakes, or we try and like to see if there's loopholes and ways around stuff. So if you want to prove it, you got to say it. And so you go, okay, AC is congruent to AC. Oh, I had that up here, and so I can drag that and put that in my proof and erase my terrible handwriting. And how did I know I could say that? Well, you are congruent to yourself. You're congruent to your, so your reflexive property. You're congruent to the person that is in your reflection. Well, that is a side being congruent to a side. So now I have something that has two sides and an angle. So I definitely am not using side, side, side. And I'm definitely not using angle, side, angle. So what I have to figure out is which one of these things, wait, that's got two angles. So I had a side, and an angle, or a side and an angle and a side, okay? Well, first of all, I'm not allowed to use this one at all. You remember that from last time. If you have this, you put that backward by mistake, woo, you're going to be in trouble. So you can't use that one. But then you double check, do I really have side, angle, side? Well, I have a side here, and then it's connected to the other side, and the congruent angle is the one that's in between them. It's sandwiched in, and it's just sandwiched in here. Let's check my blue triangle. I have the top and the diagonal, they touch, and then the angle inside them, the one sandwiched in between, is my congruent one. So I do indeed have side, angle, side. The order you have them listed here is not necessarily going to be the order that you use in your congruency name, because you might have angle, side, angle, But you might have proved both angles congruent first and then figured out the side or something like that. So the order is not going to matter in your proof. It's just going to matter where they are in the picture. So I can go ahead and say that yes, these triangles are congruent because I had side, angle, side congruency. Okay? So this is how proofs work. You're having to take everything we've learned all year and figure out how to put it all together into something new. So let us move on to a new one. New picture, new givens. Let's figure it out. So I'm given that AE bisects BD. So this long line here bisects BD. Okay? And so I've put that here. And then I'm given that AB is parallel to DE. So this guy is parallel to this guy. Okay, and that's all I'm given. And I have to find anything I can to prove stuff congruent. Remember, I'm trying to prove triangles congruent, so I need 3 things, right? Well, then you start looking at what you're given and you say, well, what does this tell me about anything? So let's focus on the first thing. I'm given something bisects. Well, things that bisect are cut evenly in half, the same on each side. So if I have bisected BD, that means this piece on the left is congruent to this piece on the right because AE cut it right in half. So I have that BC is congruent to CD. And so you would come over here and go, oh, look, I have BC is congruent to DC. Notice I said CD, it says DC. You're the same forward and backwards. That's your symmetric property, so you can have it said that way. So I have BC is congruent to DC. And I know that's kind of small on here, and I'm sorry. So try and hear my words, see if that helps. But this is BC is congruent to CD. And we have that because the definition of a bisector. We had a bisector, and we used that to say they were congruent. And so now I have a set of sides being congruent. Okay, so now I either need 2 more sides or I need some angles. So you start looking and you go, well, I've bisected. Well, I've got this parallel now. So parallel lines, I can use those angle postulates that I had. I can use alternate interior, alternate exterior, corresponding. And so you look in here and you go, oh, here is this lovely transversal. So my alternate interior angles here must be congruent. Well, this is angle ABC, and this is angle EDC. We'll just call it angle B and angle D. Since that's all that's there at this corner, here will be angle B, here will be angle D. And so those two are congruent. Come here, angle B and angle D, right there. And how do I know those are congruent? Well, because I had parallel lines and alternate interior angles. And alternate interior angles are congruent when you have parallel lines. And so I'm going to use my alternate interior angles to say that those were congruent. So I had some sides congruent. Now I have some angles congruent. Well, that's used up all my given stuff. Is there anything else I can possibly do? And then you get excited. Aha! I know that if I have 2 lines crisscrossing, that makes these vertical angles here congruent. Vertical angles are always congruent. And so I can take angle ACB and angle DCE and say that they're congruent. And that happens to be this set right here. But it's these 2 orange angles. I can say those orange angles are congruent now because they are vertical angles. And so I put my reason as being vertical angles. And that gave me another angle being congruent. So now I have 3 things. Now let's see if they're set up to prove my triangle congruent. So now let's look. I have an angle here on the end, this blue angle. I can follow down the congruent side to touch my orange angles being congruent. So I have an angle at the end, another angle in the middle, and then the side that's sandwiched in between them. So I am using the angle side angle congruency. And so I can say that these triangles are congruent by angle, side, angle. Now notice something. I didn't find them in that order. I found the side first. Then I found the two angles. But the way they are arranged in the picture is that I have angles and then sides and then angles set up on the triangle. So make sure you're careful when you write down what your reason is, that you put the pieces in the order they're arranged on your diagram. Okay, let's do one more just to show you what happens in different circumstances. So now I have, again, I'm going to be doing a proof. I am given that AO is perpendicular to BC. And so in this picture, I immediately start thinking, oh, perpendicular things, that's gonna be important. I know stuff about those. That makes right angles and things. So you keep that in mind. And then you have that angle B is congruent to angle C. So I put in my givens. Now I'm gonna start marking my picture. So angle B is congruent to angle C. Oh, that's a set of angles in the two triangles being congruent. So I can say that I have some angles congruent. Notice I'm trying to prove this orangey guy right here is congruent to this green or yellowy guy, trying to match the colors on the screen here. So I've got a top triangle and a bottom triangle. And now I've got one angle in each that is congruent. Well, let's focus now on my other given. I was given that these guys were perpendicular. Perpendicular things make right angles. And so now I can say that this angle and this angle are both right angles. Okay, well, let's see. Oh, yep, angle AOB and angle AOC are definitely right angles because they are perpendicular. That's the definition of what perpendicular is. Well, that didn't tell me anything was congruent, but I can say it in another step now, because now that I know I have right angles right here, now that I know they're right angles, I know that all right angles are going to be congruent because they're all 90 degrees. So I can say that they are congruent because right angles are always congruent. That's called your right angle congruence theorem. But you've known that because right angles are all 90. 90 is always equal to 90. We just call it the right angle congruence theorem. So now, after taking two steps, now I can say I have another set of angles congruent. I have these angles on the end, and then I have those two right angles in the middle. Now I need to find something else. Well, I don't see anything about these little angles. Oh, but you know what? These two triangles are touching. Anytime you have triangles touching, you want to start focusing on that shared side. And so both of the triangles have this side in common. And anything that is itself is always congruent to itself. So I can say that segment AO is congruent to segment AO because, of course, the reflexive property says you are always congruent to yourself. So let's look at what pieces I have now. I had an angle, I had another angle, and now I just found a set of sides that were congruent. Now it's arranged AAS here. Let's see what arrangement we have in the triangle. So in the triangle, if I start at the side, I follow it along, I touch an angle on the end, and then the third angle is hanging off the other way. If I start at this outer angle, I go over the closest next piece that they share is another angle, and then that side is hanging off the end instead of being in between. Well, side angle angle is the same thing as angle angle side. It's just going different directions. And so I can definitely say that the two triangles are congruent, and you can decide whether to call that angle angle side or side angle angle. In this case, they wrote angle angle side, but you can call it whichever you want because they're the same thing written forward and backward. And so that is proving triangles congruent, guys. Remember, you've got 3 steps that you're always trying to follow. You're wanting to look for 3 parts that you can somehow prove are congruent. You want to list them all in your proof. Sometimes it will take more than one step for each one, but you can do it. And then at the very end, always figure out for sure which of your congruence postulates you used and write that down as your reason, and you will be able to prove triangles congruent. Now, what if the triangles can't be proven congruent? Well, then you got a problem, and we probably won't ask you to do that in a proof. So good luck. Thank you guys. Have a great day.